security analyst for their ACERT team, performing applied research on new technologies and solutions to defend against DDoS attacks. He's 18 years of experience working on internet security, IoT security, cloud security, SDN security, core network security, and DDoS attack mitigation. He's an inventor and principal of the Cisco Autonomic Network Initiative with a specific focus on security automation, where he holds a number of related patents. So please join me in welcoming Steintor to the stage.
Thank you. So, good morning. I like security. I like finding out how things work and how to break them. And usually that is followed by finding out, okay, this is how you break them, and then this is how you fix them. And that's the reason why I get a salary, because I like fixing things as well. So this presentation, I've been with Apple for 2.5 years now. Came from Cisco, like you just heard. And DDoS security is interesting. It goes up and down in waves. There was a lot of things happening a few years back, then it got a little bit quiet, then it came up again, and so on. And the reason for this is that DDoS has now become a tool for stating your opinion. If you don't like someone, you attack them. If you are playing an online game and you lose, then you attack that guy because he must have been cheating or whatever. So DDoS is used for all kinds of things now. But when I was creating this presentation, I was going to go for the nice, fluffy one, good to hear in the morning while you drink your coffee and wake up. But based on what has been happening in the last 2 weeks, I decided to change the angle totally and try to explain this really serious situation we are in now. And I would say, unless we do something, and then unless we start working together, I mean, you guys, you service providers, start to help us to solve this problem, this could be really, really serious. So, let me begin by asking you a few questions. 7.7 million. What does this number mean? Beers? Number of beers drinking yesterday? No, that's a little bit too much. 7.7 million is the number of IoT devices connected to the internet or to an IP-based network on a daily basis. And during my presentation, about 160,000 new devices will come online. And almost all of those devices have no security. And I mean no security whatsoever. Okay, we're talking about light bulbs, things which can change colors back and forth. You don't need security on those because they're behind in your network, they're behind firewalls and so on. Or, yeah, so you thought. The bad guys, they know how to read basically everything and anything now these days. So keep this number in mind. 1 to 500,000. What is this number? This is the DDoS amplification factor for something called the memcached service, which has been all over the news in the last days. Meaning, if I send 1 byte, or actually 1 packet in this case, to the memcached service, I can make it send out reply with 500,000 packets. Actually, to be more exact, I tested this in the lab, 516,436 packets, which is a lot. And I'll go into a lot more details in a second. But this is crazy, totally, absolutely crazy. Another number, 31.4%. Okay, I'll tell you. This is the number of ASNs around the world which allow people to send spoofed packets. Meaning their customers and devices on their networks are allowed to fake the source IP and send out packets to the global internet. Almost everyone in Europe, and especially you guys, you're really good at this. Really good at fixing this and not making sure your customers are doing the right thing. So that's good. The problem is people in certain other regions of the world, Eastern Europe, Asia, and so on and so on. And there are some exceptions around Europe and the US and South America, because they don't care. And the thing is, I'll come back to it a little bit later on, but if we could solve this, then reflection-based DDoS attacks wouldn't exist. Because this is the basis of sending a reflection attack. I pretend to be him, and I'll call and ask for 1,000 pizzas sent to his home. That's a reflection attack, because I'm faking your identity. If I could fix that, well, you'd have to order your own pizzas. And that's, yeah, that makes more sense, or I can only order pizzas for myself. 1.7. Someone must know this. The biggest DDoS attack seen on the internet, and this happened February 25th. And this was using the memcached service. 1.7, if someone hits you with 1.7 terabits of garbage, you have a problem. Everyone has a problem. The good thing is, this attack was actually mitigated, because if you begin to go into technical details of memcached, it is not that difficult to mitigate. But it shows you how quickly and how aggressive the attackers can be when they see a new opportunity to take advantage of it and then use it. So, because this number blows basically everyone away. And it's so easy to implement and to use. So, how did we get into this mess? Well, number one, the attackers, they come in many shapes and forms. These are the clever guys. These are the ones who come to these conferences, like this one, sit in the back. I'm not pointing you guys out, but they sit in the back. They really understand how the internet works. They look at new release, they examine the code. They take a look at the operating systems. They look for vulnerabilities, and then they create tools. They really go into the business of developing new ways to attack infrastructures and systems and so on. And they do live field testing. And I'll have two examples of that a little bit later on. But these guys, they never attack anyone. They manufacture weapons for others to use. These guys, I would like to call them the DDoS mercenaries. Those are the ones who run the booter and stressor services. I still don't understand why people actually believe that's a sane thing to do, boot the stressor service. But they actually sell DDoS services to anyone for what? What's the going price now? $5, $2 to launch a gigabit attack against someone? I have no idea. It's very cheap. The only thing you need today is a Bitcoin. Well, not the entire Bitcoin, that's too expensive. A tiny little fraction of a Bitcoin, and you can launch a DDoS attack against anyone at any point in time. And then you have the attackers, that is the ones who actually have decided to attack you or someone else, and they either use the DDoS services or they buy the toolkits. I'll go back a little bit. Toolkits from the guys at the top. So the guys up here, the clever guys, they just create the weapons. They sell them to the booter stressor guys, or in some cases they sell them directly to the attackers themselves. So it's interesting. And okay, we can go into all kinds of discussions. The guy who creates a weapon, should he be put in prison or not? Okay, that's a different thing. But this is how things work. And also, they are very persistent. And attacks come in waves. So if we take a look at this, we have lots of attacks happening, like what was happening with Mirai back in 2016. The attackers, they got tools to actually activate all those nice IoT devices, and they began to launch attacks against everyone, took down the east coast of the US, and so on, all kinds of cool things. We tried to resolve the problem. We tried to understand how this worked, what we could do to do this, and we tried to prepare for the next wave. Because the thing is, when the attackers see that their tools are not working as well as they should be, they of course go into research and development. Because they find out, okay, my attacks using a normal webcam, IoT device, whatever, it is not capable of taking down the services as well as they would want to, because the good guys, that is we begin to understand how to deal with this. So they go into research and development phase, come out with new approaches, new technologies, find package them, create attack toolkits, and we just try then to survive the next wave. So it goes like this. We have peaks, valleys, but the trend is upwards. And time-wise, we are somewhere around here. And the reason why I say we are somewhere around here is because we've seen a lot of this happening in the last year. New technologies, new attack vectors being tested on the internet and not used. And they don't disappear. Someone took them and actually has packaged them into something which can be used, that's used in the future. So, one example. Mirai, that is what was used for IoT devices back in 2016. And the primary way for these guys, what Mirai did was to use brute force username and password hacking, try to connect to devices connected directly to the internet, and then gain access to those. And that was primarily webcams and other things because people, well, normal people, they don't understand that it's risky to connect stuff to the internet. Actually, don't have the number here, but the situation that it is today, if you connect a vulnerable IoT device to the internet, it takes about 2 minutes before it's connected. Back in the old days, for you who remember Windows XP, it was 3 minutes for a Windows XP computer to get infected. That is before Service Pack 3. IoT devices are worse than Windows XP from a security point of view. That is unpatched XP. It takes 2 minutes before someone else owns it. But the attackers understood, okay, 5% of IoT devices are on the internet. 95% are actually behind some kind of firewalls, and you will not detect them if you scan the internet. So what did they do? They implemented what we call the Windows Mirai Seeder, which is basically a Windows Trojan containing the attack and infection code for Mirai, meaning that you go to a conference like this one, you connect to this Wi-Fi which we have here, someone infects your computer, you take it back to your network behind the firewalls, and it begins to infect all the IoT devices which you thought were secure behind the firewalls. The interesting thing, this didn't happen because this was only live for 2 weeks back in 2017, and then the attackers pulled it back. They disabled it, and we haven't seen that happening real. So I would say they were doing a field test, seeing does this technology work. We don't know if they were happy or not, but what we saw is actually this, is that when this one came, the next generation, it actually contained the same code or same technologies like the Windows Mirai Seeder. So they came up with someone came up with a new attack tool, which is called IoT Reaper, which used the same technologies like the Windows Mirai Seeder. So they paid attention and they implemented in the next generation. So this one is even more scary because this is not just taking advantage of username and password like root, admin, or whatever. It uses vulnerabilities in the IoT software itself. Buffer overflow, that is sending URLs which are too long, or // or whatever. All those things we have fixed on Linux and Windows servers many, many years ago, but are still a problem on IoT devices. So it's taking advantage of all of those things. And the reason why this made the news is that this became live. They went out there, and at one point, they managed to identify and put into a database more than 2 million vulnerable devices. They were scanning, identified those devices, put them into a database, and which we believe was a queue for infection. These were devices which we could actually take control of. But they never infected more than 30,000 devices. And then they went quiet. So they killed themselves, went offline, and we believe they were actually testing this, the solution for actually scanning, infection, vulnerabilities, and so on and so on. It had a DDoS module, which was empty. It was there, but it didn't contain any code. It was just, here is where we'll put in our DDoS code. And this could be updated online, real time, and had everything in place to become a really efficient tool. But who was developing it? We have no clue. And then we come to this one, memcached. For those who don't know what memcached is, it's basically a memory database caching service, often used by web services and so on. If you want to access something from a SQL database, you retrieve it once and then you store it in memory, because then it will be a lot quicker to retrieve it. The thing is, the default implementation has absolutely no authentication whatsoever. Anyone can connect to it. And in many cases, deployed as listening on all interfaces on the server, on UDP and TCP. Which, if you are someone who is operating our cloud service or implementing a solution for a bank or someone, then yes, maybe you do this because you need to be able to access this cache from multiple computers. But then, so you should at least try to protect this. But people don't think that way. And this is the reason why we got up to 1.7 terabits. When the attacks began, there was an estimated 100,000 of these servers out there, opened to the public internet and could be abused in this way. So let's go into details. And I'll try to explain how you actually do this. This is a script using Scapy. It basically creates a spoofed IP packet, a UDP packet in this specific case. And as you can see, it's sending the command stats. So you just open a connection to that server. You need to have these headers in place. These are the telling some sequence numbers and stuff. But then you get this back. And that is basically a factor of 1 to 19. If you take a look at the packet sizes, that is 60 versus 1,170. So that's the normal. That's something what we'll see similar to NTP, DNS, and so on. But if you want to become clever and do cool stuff, then you actually inject your own keys. Because, like I said, there's no security. Anyone can inject a key into this database. And the maximum key size is 1 megabyte. So here's an example. Payload is, this is a very long key, can't be up to 1 megabyte in size, And here you can see how this actually works. I just inject it, and I get back a positive answer saying stored. This key has been stored. If I want to create a 1 megabyte key, then I can either use TCP or I can actually use the append command. So I can send the maximum size of a UDP packet, and then I just append until I have the key which is 1 megabyte in size. Okay, and then I'm going to use it. So the key is called A, and there's 1 megabyte of basically junk. So here, the command I do is basically get space A, space A, space A, space A, space A, and so on and so on, 729 times, because that's the maximum you can fit into one UDP packet. And what will happen now is I basically send this one packet to the service, and this is the result. I send one, size 1,513. It says QRC here because I'm spoofing the destination port of the... I'm sending the source port, looks like port 80 on a server. In this case, I'm using memcached to attack a web server somewhere. And as a reply, I get 536,302 packets. I didn't count them all. I just used the statistics which I saw on my network. But one packet from an attacker can result in someone else, you, receiving 536,000 pizzas or whatever. That's a lot. Any device in the world can send one packet a second, because this actually translates into 6.2 gigabit of traffic. So I send one packet. I can send from an iPhone, I can send from a light bulb or whatever. And it will result in that server generating 6.2 gigabits of traffic. And then I send another one. And then I send another one. And so on. And that becomes interesting. The only bottleneck here is the size of the internet connection for the servers or for the data center which the server resides in. Because this will fill every pipe in existence, if you're a little bit clever. And this is how it looks like. Get A's, lots of A's, and here's what's happening. This is cool. And as you saw, how many lines of Python code? 10, 15? Any idiot can do it, and of course someone has actually created a tool now which can actually download and click a button and you will launch an attack. So anyone can do this today. And so someone came up with said, but basically there's actually a kill switch, like they would call a kill switch, which in theory should be able to stop this attack. Now I have a question for you. If you're being hit with a DDoS attack, and the technology allows you to fight back or limit or stop the attack in some way, should you do it? Those who think it's a good idea, raise their hands. Are you all asleep? No one? Good, because the answer is definitely no. I was trying to bait you. The reason for this is, if you're fighting back, if you're sending a command back to the attacker, then the thing is, the attacker is in almost all cases abusing someone else's system. So if you're being attacked by what looks like him, and you send a kill switch to him, I don't care because I was attacking you. I was sending spoof packets to him, resulting in him sending attack packets to you, and you just caused his system to crash. Okay, maybe it was not working very well because it was being used as a DDoS vector, but you are basically taking him offline. And he's also a victim in this case. And yes, there are laws, and I live in Norway, which actually go directly into this. You're not allowed to influence or cause problems with the operations of a computer system. And you would be doing that if you're fighting back. Yes, there are some discussions back and forth, but if you do this, well, if you're fighting back, would you use your own source IP when fighting back? You should do it. If you spoof it, then that's the difference between you and me. Basically none. So don't do it. And the thing is, this is falling off. We have ways to solve. We can defend against attacks. And there have been multiple instances of people coming up with ideas. We could do this. If I'm being hit with a TCP flood, I can send back Windows quench commands and all those things. It's a very slippery slope and will only lead to bad things. Because the scary situation is, if we begin to fight back, and especially if we get automation into this, then in the end we'll have basically full-scale wars on the internet, one system attacking other one, which is then fighting back to stop the other one, and it will be a total, absolute mess. So if someone says this, then say definitely no. It's a very, very bad idea. It will not help you. It will not solve the problem, because the attackers will just come up with a new way, and will just make things a lot worse. And it's immoral, and then and plain stupid to do this. So what are we doing today regarding this? How are we to defend this, solving this? Number one, the general public. Well, they have no clue. Basically, they don't understand security. They will always buy the cheapest solution available. If you go into a store and want to buy a webcam, and you have one webcam for 1,000 Swedish krona, and you have another one for 1,200 Swedish krona, and the only difference is that one says secure, you'll of course buy the cheap one. It gives you the same thing, you get the picture. If it gets used by someone else, well, you don't know. And maybe it will misbehave once in a while it's launching an attack against someone, but you don't care. Then we, the experts, number one, developers are often, they don't understand security. They're getting better at this, but they're very bad at network security. Solution designers, the ones who create those solutions from the different components, they often don't really understand those things. Like if you build a solution using a caching service and you open it to anyone on any ports, maybe you should tell the security guys, please block this port. But no one has told them about these things, and they don't often think in these ways. And here's the worst one, basically. There's a number of service providers and hosting providers who do not care. And when you ask them, you say, well, no one is paying me for this. Or, actually, like in one specific case here in Europe, then there was this hosting provider which sells VMs. That's basically, you can run your VM at their location. And it's extremely cheap. You pay $5, $10 a month or something. But they charge you for the bandwidth, which you use. In this specific case, they were told by a security guy, which I know, that in the data centers, there were a number of memcached servers which are actively being used to launch DDoS attacks, outbound DDoS attacks from their data center. And they said, basically, I don't care. I get paid per byte outbound. So in this case, someone has deployed his VM in this specific data center. He forgot about the security. It is being abused, such as launching a constant 1 gigabit outbound traffic. And the only way that guy will detect this is when he will get the bill from the hosting provider for a ridiculously high amount. Because the hosting provider makes money by having, in this case, the systems of the customers being attacked and abused. That is not good, basically. But some people think like this. And also, and this also goes back to the spoofing and so on and so on. The good thing is, the Nordics and we are pretty good at this. So, what can we do? The solution is, as usual, it's basically hard work. You have to do some things. And number one, get rid of spoofed IPs. If we can do that, we'll solve the reflection problem. Memcached wouldn't exist as an attack vector if we would get rid of spoofed IPs. Like I said, you are doing that, mostly. You have to protect your own networks. You have to scan your own networks. You have to scan your customers. You have to make sure your CPs are okay. There have been a number of service providers who buy cheap CP devices from somewhere which are then being used to launch attacks. We just had a customer in Africa where the entire network was down because the CPs, the customer CPs, which the service provider deployed, were all busy generating DDoS attacks, and basically their customers couldn't get online. So the entire network was down because they had, well, bought the cheapest CPs available and didn't update them. And here's the main thing. Requirements. Make strict requirements of yourself and also of your peers. And I know this is new. If someone wants to connect to you and you know that their system is full of bad stuff and they don't care about spoofing and so on, should you really pair with them? Or should you actually increase the charges? Pay me more because I know you will be sending garbage in my direction. And this is an example. This is actually, you know this guy. I think he was presenting here last year. This is their policy. They implemented rate limiters on all external-facing interfaces, also including customers, because they don't trust their customers. So in this case, this is an example of how you would basically rate limit all the most common DDoS attack vectors, NTP 1919, and here memcached 11211, and they apply it to their customers, they apply it to the peering and so on, and this basically ensures, number one, they won't have a problem, and if their customers have a problem, they're not generating terabits of garbage outbound. If the customer says, no, I need to be able to send terabits of NTP traffic or something, okay, fine, charge him 10 times whatever, because it will be abused. But this is the default policy which they have in place. And I think if everyone would start thinking in these ways, make requirements, block things, we would be a lot better off. We need to start to become critical of what's happening. Because the attackers are very clever. The attacks they're generating are becoming more intense, they're becoming more powerful. And if we continue to think everything has to be open to anyone, and we don't care who is sending us attack traffic and so on, then we will basically have, the problems we have will basically increase. So we need to become a lot more skeptical and maybe, like it was said at the bottom, make requirements of the ones you peer with, which you connect to. More information on this. This is our security report with all kinds of graphs and details and stuff which I didn't cover. Questions? Thoughts?
So we have time for one quick question for Steintor.
Hello.
Hi.
This is Mem at Netnod. I just have a comment. When you talked about these webcams that you buy the cheapest one, you say that people doesn't care. I think that's a bit rude. I think that people doesn't know.
They don't know, and there's also... Okay, Alex, I'll sort of agree with you, but there's also, we don't explain things to them. People don't realize the risks of buying bad things. People buy cars today with brakes. You couldn't sell a car to someone with no brakes. And again, the reason why you have to have brakes on cars is because there's a regulation for that. But I'm not going to talk about regulation of the internet now. That's a really scary thing. But still, people at least understand they need to have some kind of security for almost everything except IP-based devices.
Okay, if there are any more questions, maybe take them into the coffee break. But for now, please join me in thanking Steintor.
Okay.
So the second speaker in the session today is Milko Alari. He's the head of international business and strategy at Enter. He's been working in the telecom industry since 2002 and today is responsible for Enter's international expansion and growth. In January of this year, he announced the launch of a software-defined wide-area network service based on Enter's national and international network infrastructure. The solution is purpose-built to serve both enterprise and carrier customers, and he'll be presenting on to the cloud and back. Please join me in welcoming Milko to the stage. Thank you.
Thank you. Hi, everybody. So today, I would like to share with you some experience, vision that we had in our past years from working on the cloud and the network. So I'll give you a short introduction about us, and then I explain what we learned about our journey. So, and who is Enter? Probably most of you don't know Enter. Enter is an Italian ISP that is in the market since 22 years. We have our infrastructure in Italy. We work a lot in Italy and expanded our network over our country. And in the last 6 years, we changed a lot because we started to approach the international market. So we expanded all over Europe. So what's the key aspects of our company and what allowed to grow us so fastly? So we are a small company, and we always been very, very flexible and quick in what we do. And what we learn is not to reinvent anything and try to use all the possible solution and to be smart in using what we have. So another important aspect is that we believe a lot in open source. So to avoid any possible vendor lock-in and also be part of the community. So we invest a lot in the open source community, investing, developing, and sending our contribution. So this allowed to create our backbone in these last 3 years. We expanded a lot around Europe and also in US and Asia. But not because we are special, just because we are smaller and more flexible and quick in what we do. So our structure, company structure, is much more flexible, and so this allows us to proceed and to make decisions very quickly. In the 2012, we decided to approach the cloud market, and so we developed our cloud platform based on OpenStack. So in that time was the first European multi-region infrastructure as a service platform in Europe based on OpenStack. So we work a lot with OpenStack community. We are part of the OpenStack Foundation, and with them we contributed a lot to the developing the components for the OpenStack platform. All our works has been rewarded because in 2015 we won the tender for the public cloud service of the European Commission. So at the moment we are one of the official supplier of the European Commission, and so every time you digit or you visit some public pages or some site of the European Commission from the finance, public, and just Court of Justice, you access our cloud platform. This idea of sharing economy has been applied to all our activities. We have a big co-working space in Milan where we share the space with other companies, mostly tech companies or startup. We have a making space where people can come there, use 3D printing and all that kind of stuff. And also we have an open education platform where people can put their courses or lessons, whatever, and then can share with other people and make e-learning or use our co-working space to make lessons. So let's get back to our topic regarding cloud. So I would like to give you this idea of what we learn, what we think that the cloud can move into the network. So what happened to the cloud? The cloud, since the past years, cloud has been a big topic, but right now we think is not anymore a big topic because people, if you look at Twitter and other social or other articles, now the big trends is like IoT, big data, cryptocurrency, blockchain. So what's happened to the cloud? Cloud. We think when people start to stop talking about cloud or a topic in general, it's because that technology is dead, or at least has been assimilated by the people. So it means that all people knows and the people use. And with the cloud is happened for this reason, because the cloud now is a stable and confirmed application and technology. But how has been possible? Because over the time, starting from the virtualization, everything has moved versus a more automated platform. So cloud now, it's like machine that talk with other machine and allow, let's call a self-implementation, and this is possible thanks to the API. The API allowed the machine to talk with other machine. So when we talk about the automation and API, we can think that with just simple coding, we can control an entire infrastructure. So from a very complex infrastructure and storage with computing, servers, a full environment. And we can consider this an infrastructure as a code. Why automation is so important? Because with the automation, we can control without any, because with a full procedure-based application, we can control the deployment, so we cannot incur in errors or human behaviors that sometimes can disrupt and create anomalies and problems. So this kind of approach has been already discussed many years ago, and this software, let's call the software is eating the world, because almost the biggest company also in the Silicon Valley focus all their core business in the application. So in 2011, Mark Anderson wrote an article for the Wall Street Journal, and he said that software is eating the world, and it was true. That's considering that that now company like Uber, Netflix, and other companies or Airbnb, for example, their core business is focused on the software, and they are algorithm that can calculate your interest or the best vacation and ever and ever. So the people that is pushing a lot on the software and the use of the software also on the daily activities, on the operations, it has been created this movement, let's call movement, called DevOps, and they strongly believe that the automation is the future of the cloud, and also the other aspects of the technology. So if we think that the machine can do by themselves using API or automation, so what will happen? Will happen that the people can reuse their time and focus on more activities and create always more. Can work on new technology or new activities or whatever. So, and focusing on the reorganization of the time and the resources can change your approach to other technologies. This has been already happened because when Amazon has been born, everything started from a reorganization from Bezos, where Bezos reorganized the team in Amazon and divided all the biggest team in smaller groups. And it is said that if you cannot feed a team with 2 pizzas is too big, so needs to split again and simplify all the projects and all the teams in a smaller ones. And from this, what we learned, in this way to split and simplifying processes and complex infrastructure, we now arrived in a situation when we can use the microservices as an idea to create our infrastructure and manage our infrastructure. So right now, we are believing a lot on microservices. We are investing a lot on understand how we can use at the maximum level this implementation. Docker and Kubernetes is one of the two that we are using and investing on our cloud platform, and we are trying to create our solution based on this in this method. So right now, what we learn and what we are investing right now with the microservices and the containers is something that we want to move into the network. So from these aspects and this way to work from the cloud, we bring it back to the network. So we are now developing and using microservices and containers to develop and testing part of our network. So, and one of the services that we implemented in the network is the SD-WAN. The software identified network is the last software, and now is implemented with the containers. We develop the services based on containers where the customer can decide what to use, and the experience is much different. So thanks so much, and this is just our vision, so I would like to share with you. If you have any question, please.
So do we have any questions for Milko? Okay, well, please join me in thanking Milko very much. Thank you for your presentation. So we're running a little bit ahead of schedule. I suggest that we break now for coffee and we meet back here at 11 o'clock for the second session. Okay, thank you.
Right. Is it working now? Yeah. Okay. Oh.
Hello? Yeah.
So welcome back, everybody, to the second session of this morning. The first speaker of the session, I'm just looking around to see, yep, there she is, fantastic. The first speaker is going to be Rebecca Klaas-Peter, as the Events and Operations Coordinator at EuroIX. Rebecca's role involves organizing and coordinating forums alongside EuroIX member hosts in Europe and assisting in the operational activities at EuroIX. She holds an MA in International Relations and Globalization and has extensive international experience in event and project management for universities and charities. So please join me in welcoming Rebecca to the stage.
Thank you. Thanks. Hi, everyone. It's really good to be here today. I was saying this is my first Netnod meeting, so I'm very happy to be here, and it's indeed my first time in Sweden as well, so that's a double. Thanks for having me. Today I'm just going to talk about the Internet Exchange Point database, the IXPDB. I'm just briefly going to give an overview of what EuroIX does. So we are the Association for Internet Exchange Points in Europe, but saying that we do have a lot of members outside Europe. Indeed, we just had the first IXP in Saudi Arabia join this week, so we're very happy to announce that. As I said, we're a membership-based organization. We currently have 83 IXP members. We hold 2 forums per year, and these are hosted by our members, and it's in a different European country each time. Our next one will be in Galway in April, and I hope that some IXPs who are here today will join us there. If you need more information, we have that on our website. We also maintain and develop a number of database and tools, which I will talk about as the main point later on. We have a benchmarking report, or we produce a benchmarking report, and this is an internal benchmarking report. So it's for the IXPs who are our members to see, what's happening in each region, what are the pricing, to compare if they're similar or different in different metrics. We have a number of mailing lists so that our members can talk to each other. We also have newsletter, which comes out every month, a number of working groups, and we are present on a number of social media outlets. So I'm mainly going to concentrate on the IXF and the IXPDB, as I mentioned before. We are part of the IXF, and it also consists of the Asia Pacific Association, so the regional associations. It consists of Africa and Latin America as well. You notice there's the big blue corner there, North America and Canada, that they're not operational with their association at the moment. So just to give a little bit of information on how the different regional associations are doing, we've just had news that there will be the next meeting for Asia Pacific in Hong Kong this year. AFIX currently have 37 members, and ISOC has also announced that they will be handing over the Africa Peering Forum to AFIX, so they'll be organising that going forward. LACIX are organising their first LAC Peering Forum, along with LACNIC, and their next meeting will be in Panama on April 30th. And so this basically demonstrates the growth of the IXF and how they're doing. Some of them has also started to charge membership fees, so we're very happy to see that growth. So, as we all know, IXPs are now considered as a core internet infrastructure, and they're carrying more and more of the world's traffic. However, while there are a number of directories and databases, there's none that's really fully, I'd say, authoritative, and that's why the IXF have come together as associations and want to build a database that will fill this gap or fill the role to do this. So currently, the big databases that we do have, some of them are done, updated on an ad hoc basis by membership admins. Some of them are updated manually. Some of them are updated, by the members. But none are fully concise, I'll say. So we aim to have the IXPDB do this. So the IXF, as I mentioned, aims to fill this gap. The key thing that the database will do is that it will acquire the data, directly from the IXPs. And this will be done through automation. We'll also be using data from third-party sources to help improve and show a more holistic view of the internet ecosystem. And one of the key things as well is you'll be able to do with the system is to provide interesting reports. You'll be able to have visualization of trends, and it will show you how, the changes of IXPs and of traffic data. So as you can see, the IXPs will have a direct export to the database, and this will be done through Web GUI and APIs. So here is some of the database content, and this will be the primary data from the IXPs about the IXPs. So this will be mainly the data which the IXPs will have automated about their members. So it will contain detailed information on the networks present at each of the IXPs. So it will have information such as port pricing, peering policy, and others. I'm not going to read that out. I'm sure you can see it for yourself. Just give you a moment. So you might be thinking, this is very interesting, what I'm talking about, and it's, it all sounds very good, but what does that mean for you, or what are you going to do with this? You might be interested to know that, what trends are happening in your region. So you'll be able to see, join dates which help identify new participants. It will illustrate growth trends over time. As I said earlier, there's going to be a visual aspect of this, so you'll be able to map this on the database visually and see what's happening. So as it says there, you'll be able to see the aggregate growth, traffic, and how this correlates to trends. And as new members join, this will also be more illustrative. So something else that might be useful is that you'll be able to see what types of networks are connecting to the IXPs. So you'll have categories such as, ISPs, gaming, transport, CDNs, and these will facilitate the exact mix of networks that you are looking to pair with. So you can also use the compare function to see which ASNs are unique to that internet exchange. So as we move further into development, you'll be able to have much more refined queries that will include info such as what routes are being offered at that exchange. And this will help you again because it will help to see which ASNs are unique and to see which AXNs to join. You'll be able to see also which regions are performing better across certain metrics. Again, you can use the compare tool, and you can use it to compare against other IXs, other countries, other regions. And with the integrating map-based visualization of query results, you'll be able to see on the map different changes that are going on at the IXs and how this affects the traffic. And this is something that I particularly am looking forward to seeing how this works. So, a wise man once said that automation is the key to our success. And we couldn't agree more, and which is why we are building a database which will be fully automated. So we began our work for this database in July 2017, and we've recently launched a limited version of this on the Euro IX website. But we are going to have further changes. At the moment, you can have the system is automated from 2 sources, and this is the JSON IXF member export and IXP Manager. IXP Manager actually has its own inbuilt export to the database, and you can see this information on your IX/IXPDB. There is still lots to do, and we are working very hard to bring a lot of changes. Currently, we want to work with all the IXPs to implement the latest IXF JSON schema, and also encourage all IXPs who are currently using IXP Manager to update to the latest version. We also plan to migrate the IXPDB to its own database, or its own website. So work is currently being done for that, and we'll be updating the community on how that is going. We are working with the other associations so that they can work with IXPs in their regions to do the same as well. And as I said before, you'll be able to have the integrate through WebGUI and API. So that's it about the database, but we are looking for funding for the database and sponsorship. So if you are interested or you have any questions about, or further questions about how the IXPDB will work, please do let me know while I'm here, and I'll be happy to answer any questions. And thank you.
So we have some time for some questions. Does anyone have any questions for Rebecca on the IXPDB? Right there, please.
Hi, Fredrik Nordernet. Didn't we already have one peering DB? I mean, why do we need another one? Why wasn't all this time and effort instead committed to that project instead of doing one more?
So currently, I do know that the IXF and peering DB do want to work together, so there is talk to work together and integrate this. I think on the slides, 1 second, you can see we do have these databases on the side there. So we are working, talking together to do something.
Because for me, I would turn those things around, right? I mean, because you work with IXPs, so you essentially harvest the information that IXPs have and present them. The information that IXPs is not always correct, of course. I mean, when I joined AM6 like 45 years ago or something, I gave them. I mean, I've never updated my information with AM6 essentially. So, but I take care of my own information, so I do that on PeeringDB. Mm-hmm. So this is going to be a really hard job to sync these sources of information together. So I would really like to see how that will do in the future. Yeah. And also, I mean, there's a lot more that is happening on PeeringDB than just getting information about IXPs and what people do at IXPs. I mean, there's tons of really good entries on PeeringDB that has 0 IXPs listed, but people use it for targeting PNIs and that kind of stuff. So it's going to be interesting to see how, who is the actual authoritative data here. I'm still thinking that PeeringDB is going to be the authoritative data, and you will just be cloning it. But we'll see, I guess. Well,
the main thing that we want to do is to have this automation. And for me, that will be what will, enable the IXP to have more accurate data, as I said before. So, and I also mentioned we will be working together, and we are talking with PeeringDB. So,
good. Make it one database. That would be great. Thank you.
Thank you.
Any more questions for Rebecca? Okay. Well, please join me in thanking Rebecca for the presentation. Thank you. So the second speaker of the session is Stefan Neidlinger, the Vice President, Strategic Alliance Management at Adver Optical Networking, where he plays a key role in promoting and shaping the company's optical and Ethernet, SDN, and NFV portfolio. He's one of the founding members of the WDM Passive Optical Networks Forum and member of Cable Labs working groups. And before joining Adver, he worked at Siemens for 16 years, where he was involved in the development of a range of networking technologies, including fiber in the loop, hybrid fiber coax, twisted pair, metro and backbone DWDM systems, and passive optical networks. So please join me in welcoming Stefan to the stage.
Well, good morning and hello. So actually, when I was preparing for that conference, and when I was actually looking at the agenda and all these higher layer topics we are discussing, like automation and Internet of Things and segment routing, I thought, hey, these guys really going to be bored, yeah, when I will take them down, really down to earth now and talk about optical connectivity. And that's specifically just before lunch and after that evening yesterday. But then actually, since I'm here, I thought, hey, these people are talking about exactly the same topics like I do in my layer. Yeah? We talk about open architectures, we talk about APIs, we talk about low power consumptions. And that's actually also a content of my presentation. So I think you're going to survive the next 30 minutes. Yeah? So actually, what I would like to discuss is there a dependency and a relation between higher speed router interfaces and the concept of disaggregation and open optical networks? Yeah? And then maybe even more importantly, how will we manage and operate such disaggregated and open architectures? So let me start with the disaggregation topic, a topic everybody is discussing, and yes, it arrived in the optical layer as well. So I think historically, so up to now, we always had a kind of a disaggregation between the layers. So typically, people were using different vendors for the optical system and for routers. And so kind of vertical disaggregation, how I like to call it. And there would be some network level APIs between the layers so that you can do multi-layer network optimization. I'll come back to that one a bit later. So this is something we have done quite a while. These days, people are also talking a lot about full disaggregation of the optical layer, yeah? Like we are having that in the packet layer so that each and every network element could come from somebody else. Each and every network element would have a separate API. However, the optical layer is still an analog layer, so we've got a lot of analog parameters and impairments we have to deal with. So with fully disaggregating, people already see this would basically move the integration effort all the optical vendors are spending right now to the operator. So he then would have to do all this work, or to a network integrator. And of course, as you can also see, and I think this was also one of the topics of this, I think it was called One Network talk we had yesterday before lunch. It would also we would also see many APIs, because every network element would have an API, and all these APIs would have to be managed. So I think a reasonable interim step, and this is something everybody is starting to use now, is this partial, how we call it, partial disaggregation, where the optical layer, so the layer between the router ports, if you will, would still come, would be subnetworks, would come from one vendor, where this one vendor would do all the integration effort, and could also optimize the system from a performance perspective, but where the interfaces, and we call these interfaces in the optical domain typically transponders, but these interfaces could also be interfaces directly in the routers, would be disaggregated, would come from somebody else. And this would then also limit the number of APIs, because then you would have one API for the optical layer and one API for each transponder. So this partial disaggregation is something which is very popular now. We are starting to implement that. There are also specific information models now from an API perspective. I'll come back to that one. There are still too many information models from my perspective, so this is not helpful in the industry, but I'll come to that one. So this is good. It's also making sense from a life cycle perspective. So an optical fiber system, typically has a lifetime of approximately maybe 10 years. So people won't change the fiber plant every year. That's would be much too expensive and difficult. So 10 years, I think, is a good number. So the fiber plus the optical system would be in place for that time. The interfaces, transponders, how we are calling it, are changing much faster. I think 3 years is a good assumption. So we used to have 10 gig earlier, then we moved to 100 gig. Now we're introducing 200 gig. These days we are talking about 400 gig. So 3 years is a good assumption. And so from this perspective, separating the interfaces and the transponders and the line system is also making sense. So this is kind of state of the art. I'll come back to that. There's just one issue, how to operate it. But I think from a purchasing and from a multi-vendor flexibility perspective, it's making sense. Now, question, if the line interfaces, the data rates are increasing from 100 to 200 to 400 gig going forward, will this somehow depend then on the optic layer? Will this disaggregation be possible, or will these vendors have to talk to each other so that it will work? And I have to a little bit to explain what we are doing in the optical domain. This red is a little bit light, but anyway, so that you understand where the issues are. So up to now in optical communications, we've basically been using so-called direct detection principles. So we are basically modulating the power of the light wave. So simply spoken, turning it on and off. And with that, we can basically transport a binary digit, like call it 0 and 1. And then the receiver basically has to detect if a signal is coming or not. You can distinguish between 0 and 1. If we speed up the transmission speed, then we will reach a limit for the electrical processing, like the amplifiers and everything needs to be faster and faster. So there is a limit. You can do that. You cannot do that with more and more bandwidth. So one option here on the direct detection side is basically not to transport just 1 bit per symbol, but several bits per symbol, maybe 2 bits per symbol. 2 bits would mean you would have four options or constellation points. So what people are now doing is basically transmit 4 amplitude or 4 power levels. And we are calling this amplitude modulation, or with 4 levels, or PAM4. So PAM4 is maybe a term you've heard already. So there are pluggables using this PAM4. And we will see how this PAM4 transmission will be affected by the optical line system, if this is something which needs to be considered. So that's something we can do on the direct detection side. And if you want to go higher speed, like 200 gig and 400 gig, this is not enough, And then we have to use now a different option we are calling coherent optical communication. This is something every radio and TV receiver is using. So we're basically adding a second light wave at the receiver and to the incoming light wave, and then there will be a mixing process in the photodiode. And if these wavelengths are close to each other, or maybe identical in the ideal case, then one of these mixing products is just a mathematical calculation, will be in the baseband, so that the frequency spectrum from terahertz will be moved to the baseband, and then digital signal processors can process the signal. And now we can add more parameters of that light wave, not only the amplitude or power, but also the phase. So we are using 2 phases. We're using a in-phase component and a quadrature, how we call it, component. This is this QAM principle. This is something we are also using in mobile communications or in cable networks. And then we can introduce it's a little bit light, this red here, even several amplitude states, and like with 16 QAM, we would have 16 constellation points, so we can transport then 4 bits at one time, and so on and so forth. So you can increase the transmission rate, with this higher order modulation schemes, how we are calling it. However, the complexity, there will be more complexity because we add this local laser width and this digital signal processing. So let's see how these basic principles in optical communication now affect the optical line system. And let's start with the coherent detection. This is state of the art for higher speed transmission, specifically in longer haul networks these days. This is now some examples. So the current 100 gig technology for longer haul networks, up to 3,000-4,000 kilometers, depending on the number of nodes in between, is using QPSK, so basically 4 constellation points. 200 gig is something we are just introducing, and here at 200 gig we are using the 16 QAM I just explained. However, there's also a trend now that 200 gig would be transported with QPSK as well, but then if we transmit less bits per symbol, then again this symbol rate is increasing, and by the way, this symbol per second rate is called baud. There was a guy who was inventing some codes for telegraphy, and Mr. Bordeaux, and that's why it's called baud. And you see here in blue that the symbol rate is going up. So like in QPSK, we can divide the 100 gig signal by 4. So we get a baud rate of 25 gigabaud and plus some overhead. That's then this 34. If we go down at 200 gig to QPSK, we end up at 60 baud, or rather about 60 gigabaud, which again would mean that the processing needs to be faster. And now we are starting to introduce even 600 gigabit per wavelength, and then we have to even increase this constellation points to 64 QAM, which again will introduce a higher baud rate. Why I'm talking about that? You can see that depending on the interface speed, the baud rate and the channel width in the optical system will change, from 34 gigabaud to higher baud rates, baud rates. So if you would have a optical system with a channel spacing of, let's say, 50 gigahertz, for instance, you obviously cannot support higher baud rates. So there is already this first dependency because for higher speed transmission, you have to make sure that the system would allow for a flexible frequency grid. That's one thing. And of course, the other thing is the more of these constellation points we are transporting, the higher the influence of noise will be. So that will be more difficult to distinguish between the points, and so we cannot allow for too much noise. And this is the second thing which needs to be aligned. So there will be dependency between both layers in coherent optical communication. Just to see how this is looking like from a module perspective, also these modules are getting smaller and smaller. I think currently we are around about 20 watts. So a typical 100 gig pluggable module, this CFP2 how it's called, DCO would be around about 20 watts. So that's where we are. I think we started around about 100 watt, but going further time-wise, we're around about 20 watts right now, which is a quite good number. We is the industry, of course. Okay, now moving to direct detection, because this all sounded a little bit complicated. Is the technology for longer distances, but if you just want to bridge the distance between two data centers in the city, like up to 100 kilometers, we probably don't have to spend all this effort with coherent detection. So that's why people are looking back into direct detection with this PAM4 transmission. So as I said, this is a method where you would use 4 amplitude levels. You can use a direct detection actually to bring down again the bit rate to something like 25 gigabit per second, or gigabaud, to be more precise. The people are transporting 2 wavelengths here. Each wavelength around about 50 gigabit, and then with the PAM4 you would be at 25. And so these pluggables are available from component vendors. You can use it as a QSFP form factor. You would plug it directly into the switches, and then it would be very nice if the transport system would support it as well. However, there's also a little bit of work to do. These PAM4 signals with the 4 levels, I mean, first of all, you have to make sure that the receiver will be really able to detect these 4 amplitude levels. So you have to do a very precise power leveling, in your system. And then again, because you're transporting more levels, also noise has to be taken into consideration. There's another effect, there's the so-called dispersion, which basically means that different frequencies are transported with a different speed in the fiber. That's all physics. So you have also to compensate this dispersion pretty precisely. And that would basically mean that you need amplifiers who are controlling the dispersion compensation and who are also controlling the power level. This is possible, but again, there is a dependency then between the interfaces, the disaggregated interfaces, and the transmission system. So in both cases, there are these dependencies. This is an example of what we have shown at OFC last year together with Arista, using PAM4 in their switches and then having our systems there. So disaggregation will work, but it still means that the vendors will have to talk, and that the solutions have to be adapted. I think that's a key thing. So that's also my typical message when I talk with customers. If you, Mr. Customer, want to have full disaggregation, and if you want to force the vendors, from my perspective, if the vendors won't cooperate, it will never work. Because it's easy for everybody to point to the other. It's always the fault of the other guy. So I think multi-vendor interoperability will only work if all parties are really cooperating. If the vendors are willing to cooperate because they think this is a good idea, and of course if the customer is asking for such a solution. But there needs to be cooperation between the companies. If there's competition, you can forget it. It will not work, from my experience. So this is just from an optical perspective, and then maybe another very important aspect is how do you want to manage the network and how you want to run the network if there are multiple vendors. And this is then how SDN comes into play, and this brings me also to the end of the presentation then, or the final part. Even though I'm a little bit puzzled now time-wise, but I think I've... Oh, okay, good. Okay. That's good. So I can keep on going for in the afternoon as well, if you don't mind. Just kidding. So what we have done in Sweden, I think already 2 years back, is such a full disaggregated network in the network of SUNET. This is a project we have done together with Juniper. So again, fully disaggregated. So the entire optical layer in the entire country is from one vendor. And you can already see everything what I talked about, with the long distances, the amplifiers, the noise, and so everything has to be applied here. And the interfaces and the transponders are coming from Juniper in that case, and are separate. So this is nice, because this gives them the choice, to use maybe different transponders and different routers, whatever makes sense from a performance perspective. Also, the network is flexible from a wavelength grid perspective, so that they can move to higher data rates, everything what we discussed earlier. However, still the question is, how should they manage it? And I just stolen, or not stolen. I'm using some slides they presented at the Terina conference 2 years back in Prague. I think it was 2016, right? Where they're basically showing, so again, disaggregation is nice, having optical layer from one vendor who can take care of all the optical performance, and having the colored interfaces or the interfaces in the routers disaggregated. This gives us flexibility, super. That's what we're going to do, But then the question is, how going to operate the layer? Because from an optical perspective, still the engineer wants to understand the optical performance end to end, but now the optical signal starts in the router and it ends in the router, so he somehow needs to integrate. What we have done so far is basically I wouldn't call it proprietary, but maybe legacy integration of both systems in one network management system using SNMP, which already gives this end-to-end view. Yeah, and this is of course working nicely. But from a general perspective, people are now of course moving more to standardized SDN APIs. So replacing this, let's call it proprietary network management interfaces by SDN. I think the reason is, of course, you could say this is just another name for what we have done for many years. We called it network management earlier. Now we call it SDN because it's more popular. But I think, from my perspective, there's one difference. We have never been very good in multi-vendor integration from a network management perspective in the older days. I mean, there were always these attempts of these monster end-to-end network management systems, but I think they all failed because the interfaces were pretty difficult, or let's call it comprehensive, but because they were comprehensive and tried to model as much as possible, it was difficult to implement. I think, from my experience, SDN is quite successful right now because the interfaces are relatively simple, so that integration is also simple. And there was a good aspect yesterday, that's also my big credo, abstraction. The key for SDN, from my perspective, and also the speaker yesterday confirmed that, is abstraction. In this concept, we are starting to really to abstract and only expose the absolute necessary information from one layer to the other. If you really want to have an end-to-end orchestration over all the layers and all the network segments, mobile, residential, core, router, and so on, and we would expose all the parameters to a central orchestration system, it would explode and would never work. And that's why in the past it did never work. Abstraction is key. That's why I'm saying I'm feeling comfortable, because I think a similar slide on the IP layer is something we have seen yesterday. That's all the same thing now in optical. Like I explained, we will have several domains, so that there still can be multi-vendor environments, and soon it is just one vendor, which is nice for us. In typical carrier scenarios, you would have maybe one or two vendors, one for core, one for regional, so you will always have a multi-vendor situation. But if every domain would be controlled by one domain controller, then first of all, this domain controller can already abstract and just expose the absolute necessary information. One example, what we are doing quite often in multi-layer optimization, if you want to set up a path with lowest latency, for instance, you basically need to know which links are available between the router ports. You don't need to know that there are ROADMs and amplifiers and whatever in between. You don't even know what that is. You just know, okay, there are 3 links available, and for every link, I know the latency. This is, for instance, what such a domain controller could expose. And then the multi-layer orchestrator could then choose the appropriate link with the appropriate latency. That's one example. If you want to do more, if you want to do kind of a restoration, an end-to-end restoration, and really dictate, if you will, where the path should geographically go, then you need to expose more. You need to expose some of the network elements and the available ports. So it depends on the use case. But the flexibility, this is something which is now available with the SDN APIs, and that's why I think it's successful. So this hierarchical structure is important, abstraction between the layers, and then you would have these domains. And of course, this domain could also be an IP domain, and what we heard yesterday was the subdomain controllers. I'm a big fan of these subdomain controllers, doing this local stuff, if you will, and then just giving the necessary information to the end-to-end controller. So I think that's just from my experience. I mean, we have done maybe kind of 10 integration projects into 10 different orchestration systems, commercial and open source, like ONOS and Open Daylight, and all the integrations are typically something of a couple of weeks. So, and that's already showing me that there's pretty mature and a good concept. So this is good from a concept perspective. And there's also a big discussion now to do the device management, for this end-to-end control via the SDN API. So that's fine. That's the way forward. I'm a big believer, and I know that's working out of my experience. However, there's also a negative, let's say, point to that story. There are too many information models, and I don't like that slide at all. Yeah? I don't like it because too many parties and too many people are trying to invent their own information model, yeah, because of whatever reasons, but this will not help us as an industry. Yeah? If we want to get a global standard and a global interoperability, a global multi-vendor interoperability, we have to somehow migrate to one or two interfaces, yeah, or information models to be more precise. Yeah? It's relatively okay. So easy. First of all, there are APIs on different levels. There are service APIs. There are network APIs. I think this was kind of APIs a colleague yesterday was also talking about. From a network perspective on the optical layer, so an API which would control the entire optical layer network, it is still okay because there are basically two interface types. There's one defined by the ONF. This is a little bit more transport-oriented, where you can also model network elements and ports so that you can determine where the path should go in this end-to-end restoration example, for instance. And there is IETF. I'm a big fan of IETF, actually. So this is the interface we are using in all these multi-layer optimization problems, because this is obviously driven by the router people. And this is pretty abstract. So this is really just exposing the minimal optical information, like shared risk link group information, latency, like I said, yeah, and the available passes. So this is fine. So having two interfaces is okay, yeah. And you can find use cases where one fits. So, like I said, in the typical multi-layer projects, we are using that one. In the typical multi-vendor projects, we are using that interface. That's fine. But it's, I wouldn't call it chaos, but it's challenging, the situation on the device level. Yeah. So again, on the device level, of course, ONF has got a contribution, IETF, but there are also other people coming up. Yeah. There's a open config standard, yeah, which is really driven by the internet content providers. Yeah. So from this perspective, since these are important people, a big market, I mean, this is an important information model. I understand that, yeah, and we have to support it. Yeah. But there are other people who are coming up with information model called OpenROADM. There's the telecom infrastructure project. So like I said, this is, in German we all say, this is coming up like mushrooms. Yeah, so that's a saying we're having in German. But this doesn't help, yeah, because if we are implementing that one and Sienna would use that one and Huawei that one, just as an example, yeah, we will not get interoperability. That's why I'm, wherever possible, I'm trying to fight against this variety of devices. This is something we need to solve. Yeah? So, and starting to invent new interfaces doesn't help. Yeah? And I can already see a tendency that some operators, because of that situation, are trying to define their own stuff for their own ecosystem. Yeah? But then, again, this will not help. So I think if I look at all these options, we need to deal with open config. Yeah? And it's people are using it, yeah. And we know that there are the Microsofts, the Googles. I mean, they are talking about it. They are starting to implement it. They are using it. It's relatively simple, that interface. So it's making sense, yeah. And like I said, we need to deal with it because of the market presence, I would say. I think I'm a big believer of the ONF core model. I think they are doing a quite good job because they're trying to align with all the other standardization bodies like ITOT and MEF and so. They've already done a pretty good job on the network level. So from my perspective, from my recommendation, I mean, I would focus on the ONF core model, yeah, because of this global standardization approach, and then on the open config. Yeah. But like I said, this is still some homework, and this is something which is probably currently also a little bit delaying the practical implementation of SDN on device level. Okay, so basically, I hope I brought that across. Yes, there is reason for disaggregation. It's making sense. Yeah, it will give us more flexibility. Partial integration in the disaggregation and optical layer will decrease the effort on the operator side. So that's also making sense. There is a dependency, however, because of this analog behavior of optical transmission. So the transponder side and the optical line system side, they need to cooperate to come up with a reasonable system. And the key is really the operation sides of things, yeah. Definitely using SDN, but really trying to limit the number of information methods, and then the thing will be successful, yeah. All right, that brings me to the end of my presentation. Thank you.
Okay, we have some time for some questions. Any questions for Stefan? Oh, one right here.
Michael Abrahamson. So what about, I didn't see any mention of NetConf at all in the presentation. You spoke about Yang models, but not NetConf. So what about speaking NetConf directly to the ROADMs and to the amplifiers and so on?
Sorry, I forgot that. So NetConf would be the protocol, yes. I mean, everybody will use NetConf and Yang model language. But there still needs to be an information model below. So yes, all these interfaces are using NetConf as a protocol. But the question is, how is the information model?
I understand that. But you had before, you had systems speaking to systems that spoke to the components. Mm-hmm. I want to speak NetConf directly to the amplifiers and the ROADMs.
Correct. So
okay.
So that's this would be exactly the architecture. You would have NetConf interfaces directly to the amplifiers, but still the question is then how do you model the amplifier?
Absolutely.
And then you can do open ROADM, or you can do open config, That was my point,
Oh, okay.
But it's all NetConf,
Okay, so both layers that you said, these are open interfaces.
Right.
That's Yang models and NetConf.
Yeah, correct,
Okay.
So sorry, you're right.
Okay, thank you.
I should have mentioned that. I mean, we also, maybe just a comment, because that's a good point. So we also started with OpenFlow in the optical community, but then we clearly saw the limitation. I mean, as we all know, OpenFlow, how it was invented by Stanford guys and so for packet matrices. So it's not really suitable for analog or optical networks. That's why I think the whole industry moved away from OpenFlow. We started to invent some extensions for it, but it didn't work. So I think consensus is now everybody's using NetConf and Yang, but then the question is, how is the information? But that was my point. But thank you. Good point.
Any more questions for Stefan? Okay. Well, please join me in thanking you for a very nice presentation. Thank you. So the final speaker of the session is Christopher Larsen. He's a network development engineer at Telia Company, where he works with mass market architecture of fixed access products and the automation around them. So please welcome Christopher to the stage.
Thank you for having me today. I will talk about an experience we have done in Telia Company and are trying to continue with in other areas than where this pilot was done. Some history of IPv6 and the mass market in Telia Company. Not very well known, but since 2011, Telia has had 6 RD in all of their newer gateways. So all customers in the Nordics have had the possibility to go and enable IPv6. The first year between the IPv6 day and the IPv6 launch, we put up some special DNS servers and registered them with Google to attract some IPv6 traffic. Because back then in 2011, there was no Quad A records on the big service providers, or content providers, should be. Not really a lot of customers enabled this. Really not a lot. So there's been no traffic on this, almost no traffic. Then some years ago, we decided that our fixed access platforms needed a major redesign. So the old service design is based on multiple VLANs per customer, and customers has 4 or even 5 IP addresses, IPv4 addresses. Something that has been dragged along since QoS was done with PVCs in ATM DSLAMs. So it has some drawbacks if you want to make an application on your smartphone that talks to your set-top box, or if you want to make a call and want to use the voice over IP quality, and you have these 4 IP addresses and fixed ports on your home equipment in the bridge case. So some of this has been solved in strange ways, so you sort of have that today anyway, but we want to go to a more simple design, modern QoS, and 1 IP address per, at least 1 IPv4 address per customer, then a bunch of IPv6 addresses. Also a motivation is that Telia has been installing DSL and fiber FTTX networks for the last 20 years or so. Some of this equipment are getting old, and there's no support for lots of stuff, and there's different supports. So we want to make a model where we move intelligence out of these old access nodes. So that's why we came up with a new design. Each customer has their own Q&Q tunnel. They only get 1 IPv4 address, a bunch of IPv6 addresses. And as much as possible, we move the features into a centralized BNG, at least more centralized than compared to having 70,000 FTTX switches. You move it into 300 sites around the country. So it's not like we're moving into a design where we have 4 BNG sites in all of Sweden. But this was basically the new design. What we decided with regards of IPv6 for this design is we use DHCP v6 for both for the WAN link and for the prefix delegations. There is some options also to have like a link local address on the WAN link, but it complicates device management if you want to do that later on with IPv6. In par with what was told yesterday on 690, hopefully, or RIPE 690, we decided to use a /56 for prefix delegation, so all residential customers get a /56. And we have a /64 for the WAN link. And then we use big pools. People want to separate the pools at these 4 nibble points for easier reading IPv6 addresses humanly. So that's why we went for /40. Could have maybe went for /41, but there is a bunch of IPv6 addresses still available. /48 for WAN links. This problem by prefix delegation, that is a bit different from IPv4, where you actually have a subnet behind the customer's residential network at home. So today, your IPv4 address, that it can change, and it doesn't really matter for your equipment behind. If you change your IPv6 prefix delegation, all your equipment behind your gateway needs to change IP address also. There is mechanisms for this. You can set lifetimes for different subnets, but it's complicated, and cheap IoT devices, if they even have IPv6 support, they don't follow all these things. So it's important that you keep your prefix delegation. So what we do, instead of fixed assigning it to each customer, there is a feature to keep the lease for 30 days after the customer has turned off the equipment. So it has to be a very long vacation if you change your prefix delegation. So that's how we solved that issue. Security considerations that we made. There was earlier this morning a lot of talk about this DDoS and how much trouble that is. So you can imagine that it's for a big operator in this region at least. We did not want the risk of just enabling IPv6 on our customers and then all their PCs or IoT devices was available from the entire world. We feel that's something that they actively need to decide. So we have in the CP we have a stateful firewall that is inspecting the packets and will not allow incoming connections. Then also the same things for IPv4. You have unicast reverse path forwarding. You have so hopefully nobody will spoof a lot from our network. What we also did is abuse logging. We have updated that to support IPv6, which was actually in most cases just a matter of making sure that the length field was long enough for the long addresses. And we also updated our DDoS platform to make sure that we were on track with that if attacks are coming on IPv6. The work we did in the residential gateway is we are blocking all incoming connections, and what we are working with our vendors to implement is to have the possibility to make incoming connections. We are not there yet. There is instead of UPnP, there is a different protocol that also works for IPv4 PCP, or part of that PCP can be made in use to enable IPv6 pinholing in a way. We have also looked into, there's a draft from Swisscom, I think, where they actually do open a lot of ports incoming, and there's a list of ports that should be closed because they are known for various DDoS or attacks. We are not considering putting that on as default, but we are considering, or we've requested to have that in the software of our RGVs, so customers can go in and select, I actually want an open IPv6 internet connection. We also set up IPv6 for remote management, tier 69, tested it. We are not using it, but we think it works. QS-wise, especially for older access platforms that has no understanding of IPv6, this is a challenge that you can't prioritize your neighbor discovery in upstream in your access network. You can actually do it on the upstream of the customer because the CP or the RGV understands QS for IPv6 and can do prioritization. But the access network doesn't know what it is. It will just put it in best effort. But we see this as a minor risk, as the upstreams are rarely saturated in our network. Everybody wants constant content from somewhere, so it's the downstream. And there we can, even on older access nodes, we use either MPLS COS bits or 802.1p bits for marking the packets, so they will be the important packets. And what in a residential network, what we see as important on the internet is something like DHCP, ARP, neighbor discovery, because if they break, the entire connection goes down. So it's mostly those that we are prioritizing. For our TV and VoIP offerings, currently there is no IPv6 plan. Something to be aware of when you're doing calculations on how to scale your BNGs. Different vendors, they calculate different. Some can take as much as 4 sessions for a mixed IPv4 WAN prefix delegation. Some can go lower, and if you disable features, you can go as low as 1. It's different on different vendors. You're welcome to come and ask me if you want to hear our experience with the specific vendors. When we did this actual migration, we moved all the customers to a new BNG during a service window. Typically, that's a rerouting of MPLS soda wire. Beforehand, we set down the least times of the old IPv4 sessions to something like 5 minutes, and we moved these soda wires to the new BNG. And then within a few minutes, customers will get new IP address and call home to their TR69 server. The server will notice they are now on the new access or BNG platform, do the changes for the 6 ID, disabling that, enabling native IPv6, and also enabling native IPv6 or enabling IPv6 on the LAN side. So during this service window, we enabled for all the customers that had a router delivered from us since 2011 also. We enabled IPv6 by default. There is still an option for people to go into their gateway and disable it, but every time we upgrade software, we enable it again. We want them to run IPv6. Yeah. Overall in the organization, it's surprising how few problems we've had. Of course, there's been few minor hiccups. We ran the first initial pilot with 25,000 customers for 2-3 months, and there was absolutely no issues. It was not until we ramped up a bit, we found minor issues with Akamai's DNS implementation. Did not do geolocation really correctly on IPv6. So some clients ended up in a small private data center that had some small Akamai cache down there in Germany somewhere, and that data center noticed that they did not want to serve all our customers and put in severe rate limiting, or maybe the DDoS system did, I don't know. Some other problems we have is that sometimes Google content does not work at a specific cache cluster. And then you can have this problem on IPv6, and then you disable IPv6, and it works on IPv4 because you go to a different cluster. But it also happens the other way around, that it doesn't work on IPv4, but it works on IPv6. So it's not really, but that's the kind of problems that we've faced. And then not all of this pilot is from Denmark, and not all of the Danish accesses is our own equipment. So we also rent like bitstream accesses, and a few had very old equipment that was blocking neighbor discovery. Instead of doing with multicast, if you don't know what you should do with multicast, you should flood it in an access network like that. They just dropped it. some nice statistics. What we achieved from this pilot. It's more than a year ago, just a few days more than a year ago. But when we did this, it's also always fun to see statistics. And at that point, Denmark was, when we started, Denmark was very, very low on IPv6 penetration. There was almost no clients, and what we achieved was to get 80% of the IPv6 eyeballs in Denmark. So we were quite happy with that. Some other APNIC claims that 50% of our users are IPv6 enabled. It's I know the user counts, and that's for the fixed. It's too low, but we also have a large mobile base where they are hiding behind some netted addresses that APNIC can't see. Some interesting statistics from all our fixed customers where IPv6 is enabled. I looked up what is there actually any traffic running on this, and it proved to be 29.5% of the traffic was actually IPv6. So there is content out there. Some months ago, I heard from a Polish mobile operator where it was close to 70% of their traffic that was IPv6 for their APN traffic. So it's time to move on. So the conclusion of this that I would bring onto you is that just get it done. I know there is some of the Swedish operators that are a bit further than we are in Denmark. And I'm working within Telia company to continue this in Sweden and Finland. So we are working hard to do some IPv6 rollout together with some other changes or these same architecture changes for the access platform. Yeah. I don't know if there's any questions. That was a quick run-through of our experience.
So we have some time for questions. Anyone on V6 deployment? There's a question right there at the back.
Hello, Alexander from Carmen. Do you see any potential in actually activating legacy platforms with native V6, like ADSL, for example?
We have done that in Denmark because ADSL is still a platform where there is development. It's not sure that we will do that in Sweden, as the focus is more to move customers to fiber. But it's working. This is 60,000 of these customers or something are DSL, and even back to the old, some very old platforms.
You should do that in Sweden as well.
I will bring that forward.
Okay, a question right at the front, please.
Thank you. Jan George from Slovenia. Thank you for this brilliant presentation, and it's quite encouraging to see big operators deploying IPv6. But when you move forward and enable IPv6 by default for everybody, I hear operators around the world saying operating two stacks is expensive and complex, so we are removing IPv4. This discussion already started. Do you have any plans for the future about the transition mechanism, how to go to IPv6 only in your access network?
No, it's difficult to convince my colleagues. I bring it up every time there's a huge discussion about IPv4 depletion and small subnets and all this crap we are we're doing. Yeah, I would like a design where we had pure IPv6 and then you had some residential gateway that that does 4 to 6 to 4 or something like that. I think they are doing that in Deutsche Telekom, or I've seen some presentations on that. I don't know if they're actually doing it. But I have no experience with it, but I think it's an interesting technology. And especially on mobile, that's I mentioned this, I can't remember the name, but a Polish mobile company. It's all major mobile phones nowadays run IPv6, and you just have a 6 to 4 gateway. So it's a no-brainer on mobile, and we have test environments, but there's no set plans for it. But it's easing up within the company as this LTE forces people to know about IPv6. Yes.
Okay, one question in the middle, please.
Yeah, Michael Abramson. Yeah, you seem to be doing everything right here. It's good work.
Thank you.
What about, you said mobile in passing. What about doing anything IPv6 related in mobile across the different mobile networks? Or, I don't know, are they completely separated in the different countries, or is there any commonality between them?
I'm not working with mobile, so I've heard talk about the coffee machine, around the coffee machine, but so they are pretty similar, the networks, and they are rolling out IPv6 for VoLTE, but that's a different PDP context in the mobile phone. But I have pushed some of these guys, and we have set up some test APNs for this, but I've not heard that we are rolling anything out. There's no plans for that.
Yeah, okay. That's the same frustrating answer I get from the customer support here in Sweden. So,
yeah.
So that seems to confirm that.
We have very few people trying to push this internally. It's hard. But,
right.
Yeah.
Okay, thank you.
Thank you.
Okay, any more questions? Nope. Then please thank Christopher for his presentation.
Thank you.
So that was the final speaker for this session. We'll break for lunch and meet back here at 1:30. Thank you very much.